Hi everyone, welcome back to Code with Yusuf. Have you ever tried updating numerous duplicate data in a table? Also, try to filter it or use the repeated data in analytics. Yeah, that is how nightmares start with unstructured data. And that is why relationships in the database are lifesaver for this case. Today we are going to talk about relationships in database, what they are, why they exist, and why they are the secret sauce to keeping your data clean, consistent, and easy to work with. This is the first video about relationships, so we are just focusing on the big picture. In the future videos, we will break down one-to-one, one-to-many, and many-to-many relationships in detail. Let's start with a simple example. Imagine we are storing users in a database, and each user has an education history. It could be university name, degree, start date, end date, and so on. In a document-based database, we might keep all of data in one document, like that. It looks perfect. But there is big problem. If we have millions of the users and they carry same university name, if we try to update one university name in one document, data will be inconsistent in other documents also. That means in update operation should update all documents in a database because we are keep repeating same data in all documents. That is called denormalized data. It is easy to read, but it is pain to update and can cause data inconsistencies. Honestly, this problem isn't only document-based database problems. Same problem can occur in relation database also. Imagine we have a user table to keep user data inside it. And if we want to add one education field, we need to add one more column here to keep our university name inside the education column. However, if we want to add new educational degree, for example, in our case, that is the master degree, we need to add one more column and we need to store our university name inside it also. And the complexity can cause here because if you have seen here, one university name can be repeated in several columns, even in several rows also. Even this situation is calling the normalized data. And what is the solution? In a relational database, instead of storing all data together and keep repeating university name in every user rows, we are storing username and university name in their table. And this separation of data give us some flexibility. However, in the user table, we are keeping university ID, which comes from the university table. And that is why by sharing one ID to the another table, we are achieving relation between two tables. However, we could say relationship can occur by sharing ID between tables. Let's have a look normalized data in the tables. Here in the user table, rather than keep storing university name directly in the user table, we are storing university name in different table and we are sharing its ID from university table through user table. And by the way, it gives us more flexibility. And this solution can prevent the normalized data and keep our data constant. In the future, if we change some things related to University of Cambridge, it directly affects related data which is referenced in the user table. That's why I highly recommend you normalize your data while you design database. Until here, everything looks fine. What if we want to store user's master degree also in the user table? And we need to create one more column here. We need to arrange our relationships also. That is another type of the denormalization because more column can complicate your database and application also. And that is why we need to find out another solution. Let's see how to solve it. In this case, best solution is to add one more table, which is called user educations, and keep both table for in case inside this user education table. That said, from the users, you can get user's ID. From the universities, you can get university ID. And user educations table can store several records related to the one user. And each records can reference one university also. By the way, with the power of relationships, we can keep normalize our data inside the database. So right now, let's have a look how these three tables looks with the data. Here, this education table carry user's ID, which comes from the users, and the university ID, which comes from university, and kind of educational type. It could be university, master, or any kind of educational. And start date and end date represent when user has started education and when it has done. And that is why with the three tables, we are keeping very flexible data inside our relation database. If we have a look second rows, we see same user, which is the user 1, but with the second university, with the different kind of type. It is started and end date here, it represent. And by the way, one user can have multiple rows in the education table. That is why these kind of relationships give us some flexibility and data consistency also. So why we go through all this trouble? There is three big reasons. One is flexibility. That means user can have any number of educations, departments, or feature attributes that we can add in the future without changing user table. We just affect education table. Second is data consistencies. If we try to update any data on the university table, it directly affects in the educational also. We don't need to update billions data in the table. Other performance on the update. So if we try to update one university name, we just update on the one table and one name, and it affects other education automatically. But in the previous approach that we have seen, if we change the one rows, it should affect all documents or all tables since our data keep repeating and duplicating. That is just starting point with the relationship. In the next video, we will go deeper into relationship types. One-to-one, one-to-many, many-to-many, and how implement in the anti-framework core. Thank you for watching. Please don't forget to subscribe.